Okay, I'm going to do an introduction, our last confidence interval of standard deviation. So it's a little bit different than proportions and means. Big thing is because our point estimate is really the variance sample to parameter. And here's why it's different. If you remember back in section 6.3, this is not normal. The distribution of sample variances is skewed, so we don't get a margin of error like we did with the proportion to mean, because this is not symmetric like a normal curve. So we got to do something different. And we learned about chi-squared distribution. This is the formula for chi-squared, but remember, we don't know this, so we're going to end up using this formula to make our intervals. So we have to find two of these chi-squared values, and that's a table in the trio of formulas. That's not how we denote it, and that's ugly. We do this. Chi-squared left, chi-squared right. And when I do one, I'll show you the analysis in the diagram. So really, what we do with our analysis, over here, we're going to have a chi-squared right. Over here, we're going to have a chi-squared left value. We have to find those, all based on our confidence interval. I think we're going to do a 95%. So that means the area between this is 0.95. And what we really look at is the area to the right of each of these. So the area to the right here is 0.025. The area to the right of chi-squared left, 0.95, plus this is 0.975. So that will give us the columns that we need in our formula sheet. There's just one thing more. Degrees of freedom again. Just like with the t-score, chi-square depends on the degrees of freedom. The more in the sample size, the closer it does get to a normal distribution. So, random sample, 22 IQ scores. Okay, degrees of freedom is 21, subtract 1. Our confidence interval, 95%. So we have to find that chi-squared left and chi-squared right. They did it for us. When I'm done at the end of this, I will go into the formula sheet. But notice it was this area, but it's not that area that you look for. You look for this area, 0.975. So there's two columns that we have to do. And what the heck, let me just go find it. Hang on, I'm going to zoom down. It's like the last page in the formula sheet, of course. There's our T that we did with a mean. There's all our formulas. We're going to end up doing a bunch of them. And here we are. Chi-squared distribution. So, area to the right of the critical values. This is one column we need. This is our other column. Notice that those add up to 1. Another thing you may notice is if you look at these, here's those two are linked together, these two are linked together, these are, and so on. So there's a little bit of symmetry going on here. Okay, so we got our column. Now we need our row. That is degrees of freedom. Degrees of freedom was 21. Go down here. 10.283 for chi-squared left, chi-squared right is 35.479. And I sure hope those are our values when we get back up there. And there they are. So we've just done the analysis. So this is the diagram I would expect you to be able to draw, because it gives me everything. It gives me the chi-squared rights, chi-squareds left. I would ask that you put the 0.95, you write the areas in here, and the area to the left, or to the right, I'm sorry, of chi-squared left, 0.975. That's your analysis. Now, I'm not going to do this yet, a little bit more theory. These are everything we're looking for. Our margin of error is this, but we're not going to do it the same way as we did with the other two confidence intervals. Simple random sample, and this is kind of strict. The population has to be normally distributed. So here's our formula. Notice what we just found. We found our chi-squared left and chi-squared right. We know n, and we're given the standard deviation from the data. This captures the variance. If we want the standard deviation, we take the square root. So where's our problem? Here we go. IQ and lead. N is 22. We got our degrees of freedom. I'm rounding the standard deviation to 14.3 because I'm not going to use that big number. I want a 95% confidence interval. They plotted this for us. There's a histogram. Pretty normal, not too bad. When we do problems, I may have you do a quick dot plot, do the same kind of thing if I give you a list of data. So we just did this. We found our chi-squared right. We found our chi-squared left. Of course, I didn't write it down. I gotta go back and do it. .283. Chi-squared right is the 35.47. Oops, 9. Notice this one's the bigger one. Now, when we go to build this, because we're doing n-1, s squared over our chi-squared, this one is the right because that is the larger number, which makes this a smaller fraction. And you put chi-squared left over here because it makes it smaller, or smaller fraction for a larger number. So let's just put in our values here because we have them. Very quickly. Our degrees of freedom, 21. S was 14.3. We got to square it. Chi-squared right, 35.479. It's less than sigma squared. It's less than 21. Square that. Do this. So this is like 121.03. It's less than the variance, less than. .417. 0.61. Now, we want standard deviation, so I got to take the square root of those. So I take the square root of this. That's 20.44. Square root of this is, it's going to be basically 11. And it is 11.0. So, you know how to finish this with a conclusion. We're 95% confident that the true value of the standard deviation of IQ scores lies between 11.0 and 20.44. So in our meetings, first meeting of the week, I'll do a couple problems of this from the book, but that's chi-squared in a nutshell.